Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So I'm going to talk about horizontal asymptote of a rational function, okay? If you've not subscribed, shared or liked this video, I don't know what you're waiting for. Make sure you click the notification bell. Make sure you subscribe so that when I post new videos, you'll be the first person to know. All right, so let's get straight to it. Horizontal asymptote. The first thing you need to do, please try as much as possible to review the previous video so that because in the previous video we talked about the concept of a rational function. We've talked about the general form of a rational function. So it's better you have to go back, go to the playlist and look for the video and make sure you understood the rational function and how to play around with it. So just a quick reminder, let's just remind us of the rational function. I told you the rational function has a general form of f of x is equal to p of x over q of x plus d, okay? Where I told you that a rational function is the ratio of two polynomials. So you have the polynomial in the numerator and another polynomial in denominator with a constant. Or I told you that it's possible that for a rational function, you can have a constant in the numerator and you can have also a linear function in the denominator and a constant. Or you can have a constant and another polynomial in the denominator. And for this to be a rational function, I told you as well that the denominator q of x cannot be equal to 0, and the linear function as well, bx plus c, cannot also be equal to what? 0. All right, we talked about this. Now, let's go straight to what we have for today. Last video, I talked about vertical asymptote, how to find a vertical asymptote, and I showed you the rules on how to do it. Now we're going to talk about the horizontal asymptote. Now, when we talk about the horizontal asymptote or HA, when we say we're looking for the horizontal asymptote of a function, it's an imaginary horizontal line. It's different from the vertical asymptote, which was a vertical line. Now, this is a horizontal line to which the graph appears to be very close, but it will never touch. I'm going to write it down because I know some of you take notes as well. So a horizontal asymptote, okay, of a function is an imaginary line So I'll say imaginary horizontal line to be more specific, okay? To which, okay, its graph, I say the graph of the function, appears to be very close. All right? But never touch. All right? So for instance, if this is the imaginary line, so what we're saying, the graph is going to come very close, but it will never touch the line. All right? Good. So that's the horizontal asymptote. But remember, this is different to the vertical. The vertical asymptote was like this, where you have the line coming close to the vertical asymptote, but it will never touch the vertical asymptote. We've discussed this already in the previous video. Now, what we're going to talk about is the horizontal asymptote and how to do it now. Now, before I go in, I need to make something very clear here, all right? You can only have one horizontal asymptote for a particular function, okay? At most, the number of horizontal asymptotes you can have is just one, all right? You can't have more than one horizontal asymptote for a particular function. So I'm going to write it down. So a rational function, the rational function can have at most okay, can have at most one horizontal asymptote. So a rational function can have at most one horizontal asymptote, all right? So there are several ways of finding horizontal asymptote. There are several methods. And if you go to the textbook, there are different ways. We have the try and error method. We have the way to use the degrees of the numerator and the denominator of the function. So what I'm going to do, I'm going to just stick to one. I'm going to talk about the degree of the numerator and the denominator method because that is the fastest way I know, okay? So I'm going to use that method in this video to talk about how to solve or to find the horizontal asymptote. So I'm going to use that method throughout this video. So I'm going to write it down. For me, is the fastest way, all right? So the fastest way, all right, to find the horizontal asymptote. So the fastest way to do this. When you go to the textbook, you will see that the textbook have several other methods, but for me, I find this way more faster compared to other methods, okay? Now, it's basically we are using is to use the degrees, all right? The degrees of the numerator. So here, in order to use this method, you need to find the degrees of the numerator n and the degree of the denominator as well. So in order to find this, we use the degree of the numerator and the degree of the denominator, okay? So I'm going to be writing the numerator as n, and I'm going to be writing the denominator as d. So I'm going to be doing it this way so that I will not keep on writing numerator and denominator. All right. In order to do this, we have three rules how to do this. So the three rules on how to find the horizontal asymptote, the first thing you have to do is that you have to identify the degree of the numerator. Okay? You have to identify the degree of the numerator. Just for me not to assume knowledge, when we talk about degrees, okay, we're talking about the highest power of x. So for instance, let me just say this here. So just for some of us, I've talked about this in my previous videos on polynomials, but for some of us, just a reminder. So if, for instance, we have 3x cubed plus 5x squared plus 6x plus 7, and you are asked what is the degree for this function or for this polynomial, the degree for this is going to be what? 3. Are you seeing it? Because it is the highest power of what? X. If you have another one, let's say we have x squared plus 5, and you are told what is the degree. The degree, yes, like I can hear you saying that as well. The degree is going to be what? 2, because the highest power of x is 2. When you have something like, let's say 5x plus 3, something like this, the degree for this is going to be what? The highest power of x is here. What? Because remember I told you that when you have a constant in indices, it's the same thing as saying x raised to power what? 0. Do you remember this? So the highest power in this case is going to be 1. So the degree is going to be what? 1 in this case. Even if you have something like x raised to power 4 minus x raised to power 5 plus 7, and you ask what is the degree in this case, the degree for this is going to be what? The degree is going to be 5, because the highest power of x is 5. So that's basically what I'm talking about. I've dealt with this earlier with in my video on polynomials. So I believe before you got to this video, you've watched the previous videos on polynomials, quadratic and cubic and the rest of it. All right. So that's what we mean the degrees. So if I say the degrees of a function, I'm just talking about the highest number of a function. All right. So the first thing you have to do is to identify the degree of the numerator. Now, after you're done with that, the second thing as well is that we need to identify the degree of the denominator. All right, the degree of the denominator. The first thing, you have to identify the degree of the numerator, then you identify the degree of the denominator. Now, step 3, which is the most important part, is here that you then have to then compare step 1 and step 2 to find the horizontal asymptote. So you then what? Compare step 1, that is the degree of the numerator, and step 2, which is the degree of the numerator, to find the horizontal what? Asymptote. All right. So now when you're solving, and you notice that the degree of the numerator is less than the degree of the denominator. Okay? So the degree of the numerator is less than the degree of the denominator. So what this implies is that the P of x over Q of x will be equal to what? 0. And basically the fractional part of the rational function will be equal to what? 0. So that means what I'm saying is that when the degree of the numerator is equal to the degree of the is less than, okay? When the degree of the numerator is less than the degree of the denominator, what you then have to do is that in the rational function, the fractional part here, okay, this fractional part, what you do, you equate it to 0. Is that making sense? So that means all this is going to be equal to what? 0. So therefore, the horizontal asymptote is going to be equal to what? D. So therefore, the horizontal asymptote is going to be equal to D. So because all this is now 0, all this is now 0, the horizontal asymptote is going to be equal to D, okay? Or it could be 0 if there is no D. Okay? So what you need to keep in mind, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be equal to D. All right? Okay, so don't forget that. All right, so now, what about if the degree of the numerator is greater than the degree of the denominator? So when you find the degree of the numerator, you find that the number or the value is higher than the degree of the denominator. Then, okay, in this case, there is what? There is no horizontal asymptote. Okay? So in the case where the degree of the numerator is greater than the degree of the denominator, there is no what? Horizontal asymptote. Now, we talked about less than, we talked about greater than. Now, the third one that you need to keep in mind is when it's equal to. So in this case, the degree of the numerator, okay? Get this out. So if the degree of the numerator is equal to the degree of the denominator, okay? So now in this case, the value of the degree of the numerator is the same thing as the value of the degree of the denominator. Then what then happens? Then the horizontal asymptote is y. Basically, is the ratio of the leading divided by the ratio of the, or let's say the ratio of the leading coefficient of n and the ratio of the leading coefficient of the denominator. Okay? So then the horizontal asymptote is equal to, which is y, which is the ratio of the leading coefficients. I'm going to explain this very soon. So therefore, the horizontal asymptote is going to be the leading coefficients. It's going to be the leading coefficient of n divided by the leading coefficient of D. Okay? Now, some of you might be asking, what do you mean leading coefficient? Remember in the previous slide here, I explained to you that this is the degree, right? Now, when we talk about the leading coefficient, we're talking about the number or the value in front of that, in front of the x value with the highest degree. So in this case, the leading coefficient is 3. In this case, the leading coefficient is 1. In this case, the leading coefficient is 5. In this case, the leading coefficient is -1. So basically, we're talking about the number in front of the x that has the highest degree. So what we are now saying is that the leading coefficient of the numerator, you divide it by the leading coefficient of the what? Denominator. All right. All right, don't worry. I'm going to pick an example and explain this, okay? Let's pick an example so to make it so you understand it better. All right. So let's say we have this. We have find the horizontal asymptote of y is equal to 2x squared plus 7x plus 3 divided by 3x squared plus 5x minus what? 2. All right? So let's assume we have this rational function. This is basically a rational function because this is the p of x, this is the q of x, and the d is what? 0. We've talked about this earlier. All right? So let's pick one. So let's start. Step 1. Now, in order to find this, the first thing we need to do is to identify the degree of the numerator. So let's go back. So remember I told you the degree of the numerator is the highest what? Power of x. So in this case, the numerator, the highest power of x here is what? 2. So n is equal to 2 because we got it from x squared, right? All right. Now step 2. We then have to then identify the degree of the denominator. All right, the degree of the denominator. Now the denominator, what is the degree? The same thing we're going to do. The degree of the denominator here is what? 2. Are you seeing it? So same thing, 2. So that means this is x squared. All right. So we got it from x squared. So degree of the numerator is 2. Degree of the denominator is 2. So now, step 3, we can see that the degree of the numerator is the same thing as the degree of the what? Denominator. All right? So what do? Step 3, it said when n is less than d, n is greater than d, but we're interested when n is equal to d because we're having the same thing here. What do? The horizontal asymptote is equal to the ratio of the leading coefficient. So basically, the leading coefficient of n divided by the leading coefficient of what? D. Now, what is the leading coefficient of n here? Okay, so the leading coefficient of n, so it's going to be, the horizontal asymptote is going to be the leading coefficient of n, which is what? 2, divided by the leading coefficient here as well, which is what? 3. So the horizontal asymptote for this is equal to what? 2/3. So that means when we're going to draw this graph, the horizontal asymptote is going to be at this point here, the imaginary line. Okay? So when you draw this graph, I'm going to show you how to sketch very soon. Okay? I'm not going to do it here. I'm going to show you how to sketch soon. But when we sketch this graph, we'll find out that the horizontal asymptote is going to be at this point of 2/3. All right? So in this case, remember the first thing, you identify the n. After you identify the n, you identify the d. If n is less than d, or n is greater than d, or n is equal to what? D. Now, in this case, n was equal to d, so we then have to find the leading coefficient. So that means the number in front of the x with the highest degree. That's basically what it means of leading coefficient. All right? So the number in front of x with the highest degree here was 2, divided by the number in front of x with the highest degree here was 3, and the horizontal asymptote was 2/3. Okay, let me pick another example. Okay, number 2. They said find the horizontal asymptote okay, of y is equal to 2 over x plus 5 plus 6. So in this case, we're finding the resultant asymptote of this particular what? Rational function. All right, so let's do this. So let's go back. Step 1, we need to identify the degree of the numerator, okay? So in this case, step 1, the numerator, like I always say, when you have a constant, it's not constant, it's basically x raised to the power 0. There's an x there because anything raised to the power 0 is equal to 1. So therefore, the number with the highest degree for the numerator here, the n, is going to be equal to 0, okay? Good. Now the next thing, step 2, we then have to identify the degree of the denominator, right? Which is the step 2. We have to identify the degree of the denominator. All right, so same thing. The denominator here, we have x raised to the power 1 for it to be there. So that means the denominator, the d, is equal to 1 because it's from x raised to the power 1. This is x raised to the power 0, right? Good. Now, from this part now, you can see something here. So you can see, step 3, the n is less than the d. Are you seeing it? So in this case, the n is less than the d. So when n is less than the d, how do you find HA? When n is less than the d, the horizontal asymptote will be equal to the d, okay? Because all the fraction will be 0. So that means, yeah. So all this fraction is going to be equal to 0. So HA is going to become 0 plus 6, okay? And that will be equal to what? 6. So therefore, HA is equal to what? 6. Are you seeing it? So when n is equal to, when n is less than d, the resultant asymptote is equal to d, okay? So remember I said that. So therefore, HA is equal to what? D, all right? So that means when I draw this graph, I'm going to show you how to draw this. So when you go and draw this graph or sketch this graph, you will notice that the imaginary line is going to be at what? 6 for this horizontal what? Asymptote. All right, and that is that for that. Let me pick one more example and we'll go to the next type, which is the slant or the oblique asymptote. So let me pick one example. So let's say, but remember I told you, okay, if the numerator degree is higher than denominator, there will be no horizontal asymptote, okay? So don't forget that. All right, so let's pick another example, number 3. We're told to find the horizontal asymptote. Get this out of the way. Find the horizontal asymptote of the function. So we have f of x is equal to x squared plus 5x plus 6 divided by x squared plus x minus 2. All right? So the same thing, step 1, we need to find the degree of the numerator. So you can see the degree, the maximum value here we have is what? Of x is 2. Step 2, okay? The degree of the denominator, same thing. The maximum value here we have is what? 2. So now in this case, step 3, you can see that n is equal to what? D. Now, because n is equal to d, remember we told you that when n is equal to d, then you have to now find the ratio of the coefficients, okay? So when n is equal to d, the horizontal asymptote is equal to the ratio of the leading coefficients. So let's go back. So what is the leading coefficient for the first one? So the number here, so the first one is going to be the horizontal asymptote. Is going to be the number in front of x squared here is 1, divided by the number in front of x squared here as well is 1. So therefore, the horizontal asymptote is equal to what? It's equal to 1. All right? So basically, what we are saying is that I'm going to show you how to do this later. When you sketch the graph, the horizontal asymptote for this is going to be at what? At 1. All right? Okay. And also, we've talked about all this. We've talked about all this already. And that will bring me to the end for finding the horizontal what? Asymptote. But don't forget, like I said, if the degree of the numerator is greater than the degree of the denominator, there is no what? Horizontal what? Asymptote. So if, for example, you have maybe, let's pick an example, you have f of x is equal to 3x cubed plus 5x plus 7 divided by 2x plus, or 2x squared plus 5x plus, let's say 2 or something like this, or sorry, or 8. All right. And you were told to find the horizontal asymptote. Now, in this case, you can see the degree of the numerator here is 3. Okay. And the degree of the denominator here is, or let me put, let me make this 8 so that somebody will not get confused. And let me make this 12. Okay. Just making random numbers here. So you can see the degree of the numerator here is 3. And the degree of the denominator here is what? 2. And n is greater than what? D. So in this case, because n is greater than d, there will be no horizontal what? Asymptote. All right. So for this particular rational function, there'll be no horizontal what? Asymptote. All right. And that'll bring me to the end for this section on this. So the first thing you have to do when you're finding the horizontal asymptote, the first thing you have to do, you have to identify the degree of the numerator, identify the degree of the denominator. If n is less than d, that means the horizontal asymptote is equal to d. If n is greater than d, there is no horizontal asymptote. And if n is equal to d, the horizontal asymptote is going to be the leading coefficient of n divided by the leading coefficient of what? Of d. All right. And that is that for that. I solved some examples for each of them, and you can have a look at it. So the next video, I'm going to go straight to slant asymptote or oblique asymptote, and we're going to solve some question on it. Like I always say, if you've not like, shared, or subscribed, I don't know what you're waiting for. Don't forget to click the notification bell. So when I post new videos, you'll be the first person to know. All right, see you very soon. And I'll see you in the next video where we talk about slant asymptotes.